Hi students, today we're going to talk about steps for writing Lewis dot structures, and I'm going to look at the Prezi real quick with you for a moment. This is the Prezi, and this is where this begins, and I will have either talked to you about the Lewis dot structures for these three molecules and additional ones, and then this is a review, or you're just learning this and we'll go back over it and it'll be a review. I want you to notice that in the Prezi there's this octet rule, writing Lewis dot formulas, the octet rule. That's basically what I'm going to go over in this video. One of the ways of writing Lewis dot structures that I just kind of learned about last year. And there's also a flow chart on writing Lewis dot structures right here. And we're going to kind of use them both together. And the last thing I want to show you in the video is, or in the Prezi rather, is this tutorial on Lewis dots in the notes. This is a video I made last year. It's about 34 minutes long. And it goes through all the Lewis dots in your notes as well, that you might want to watch if you just need further review or if you weren't in class for some reason. So we're going to go back, and so the steps for writing Lewis dot structures. First thing you're going to always need, you're going to have to be able to look at a periodic table. So keep that in mind. You always need a periodic table. All right, and I've got one pulled up for us so we can refer to it. And so we'll go back over here. Here's the periodic table. We're going to be doing hydrogen initially. There's hydrogen in column 1. Everything in column 1 has one valence electron. So when we're doing Lewis dot structures for molecules, we're going to need to know how many valence electrons we're dealing with. So column 2, remember the names. These column 1, these are the alkali metals except for hydrogen. Alkali earth metals, then boron, carbon, and nitrogen and oxygen family, and then halogens and the noble gases, and of course the transition metals all here in the middle. Now we're not going to do anything with the F block. We're going to stay with the S, the P, and the D block elements. Okay? So back to here, and then we're going to talk through this hydrogen. All right, what I've done is I went ahead and wrote hydrogen down. Remember, hydrogen is diatomic, and diatomic means has 2 atom units. Remember all the diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So this is one of them. And here's all these letters. A stands for the electrons that are available. We're talking about the valence electrons. N stands for the needed valence electrons. We're always going to be dealing with the valence electrons because those are the ones that are getting shared or transferred and doing all the chemical reacting. S is for the shared electrons. And S you calculate by doing the needed minus the available, and U is unshared, or the lone pair, and that's going to be the available minus the shared. So hydrogen, in each hydrogen atom, so we have to kind of talk about individual atoms to start with. Hydrogen atom has one valence electron, and the other one has 1. So the number of available electrons for this hydrogen molecule is only 2, 1 in each atom. And the number each one needs, each hydrogen needs 2 electrons. So since there are 2 hydrogens, we need 4 total electrons. You see that? Each one needs 2, and 2 times 2 is 4 electrons. We need to find an electron. This one wants to have 2, and this one wants to have 2. So they need 4 electrons to be happy because they have 1 energy level. Remember the first energy level, if we put the proton in the middle, the first energy level would have 1 electron, and it can hold 2. It would be the 1s. It has 1s1, and we want to change it so it has 2 in the valence shell. It wants to be a 1s2. That's the desire. So the first hydrogen has this, and the second hydrogen has 1. And neither one of them have 2 in their valence shell, and that's what they want to get, to have a complete shell. So the shared then would be the needed minus the available. Shared is needed minus available. So N minus A. And that's where I got this 2. N minus A. Needed is 4 minus 2 available is 2. And then unshared or lone pairs is the available minus shared. So the number available was 2 minus the number that were shared. So we have 0 that are going to be lone pairs. So once you know that, you draw the atom, or the 2 atoms next to each other using the symbol. And if there's a central atom, we'll talk about what you do when you get there. But This one doesn't have a central atom, so we put them side by side. We're always looking to make our pictures symmetrical because electrons are trying to get away from each other as much as possible, so they spread out. So here we have, we said that we're going to share two of them, so we put those two in the middle. Anything in the middle they can share, because this hydrogen will count them and this hydrogen will count them. Now we have none that are unshared. That means no more electrons around the outside. And then we take every two electrons that are shared, we convert that over to a single bond. So this is the Lewis dot structure for hydrogen, for H2. Because how many total electrons do we have? The number available. We always check and see. The number of electrons available were 2, and the number of electrons they were accounted for in this structure is only 2. Every single line counts for 2 electrons. So that's how you do hydrogen. So let's move on and let's do hydrogen bromide. Hydrogen bromide. Okay? All right, now we're going to figure out how many are available. Well, hydrogen has 1 valence electron, and bromine, well, how many does bromine have? And you'll memorize this after a while. Bromine's in column 17 or 7A, so it has 7 valence electrons. So I'm going to draw the 7 around bromine. 1, 2, 3, 4, 5, 6, 7. And you'll notice that when I'm doing Lewis dot structures, I oftentimes put the different electrons around each atom. I make it a different symbol just so I can kind of keep up with them. So how many electrons are available? Well, 1, 2, 3, 4, 5, 6, 7, 8. Bromine has 7 and hydrogen has 1, so 8. How many electrons do we need to complete this? Well, bromine needs 8 and hydrogen needs 2, so that's 10. We need 10 altogether, okay? Bromine needs 8 to make its octet, and hydrogen needs 2 to make its 1 energy level. See, it has a hole right there, and maybe I'll put a circle where the hole is, and then bromine has a hole right here. So that's how many we need. Now, how many then are we going to share? Well, shared is the needed minus the available. So 10 minus 8, we're going to share 2 electrons. How many are going to be unshared or lone pairs? Well, unshared are the available minus the shared. So we have 8 electrons available minus 2 electrons that are going to get shared. So that's going to be 6 electrons that are unshared or lone pairs. Okay, now we don't have an atom in the middle, so we just put them side by side. And for all the shared ones, we have 2 shared electrons. We put those in the middle. And then we take all the unshared ones and we put them around. They're unshared, meaning they're not going to be between these atoms. Now, when I go to put these unshared electrons in, I'm going to put them as red here. I'm not going to put them around hydrogen because hydrogen already has 2 right here. Hydrogen is happy. Here, let's just draw a circle around hydrogen. Hydrogen has its 2 electrons that it needs for its 1 energy level. It's happy. It doesn't have the octet. But bromine isn't. Bromine only has 2. It's the one that gets the other 6. 1, 2, 3, 4, 5, 6. Now, if you count, bromine is happy because bromine has the octet. 2, 4, 6, 8. Hydrogen has 2. Now, then we turn it over, we change it and just put a line for every 2 electrons. And so if we do that, it's hydrogen with a single bond to bromine. And then we have 6 unpaired or lone paired or not shared electrons, unpaired electrons. And that's the Lewis dot structure for hydrogen bromide. Okay, let's do one where we have a central atom. Let's see here. We're going to do HCN, hydrogen cyanide. All right, now we have 3 atoms, and we have to figure out what atom goes in the middle of these guys. Well, the atom that goes in the middle, the central atom, this is important, the central atom is the most electronegative or the one missing the most. It's really the one missing the most electrons. Okay? So hydrogen has 1 valence electron. How many is it missing? It's only missing 1. Okay, carbon, well, let's look at the periodic chart. There's carbon, and group 14 or 4A. That means it has 4 valence electrons. So carbon has 4 valence electrons. 1, 2, 3, 4, and it's missing 4. Nitrogen, how many valence electrons does it have? Let's go back and look. Nitrogen has 5 valence electrons because it's in 15 or 5A, and it's, so how many is it missing to make the octet? Let's see, 1, 2, 3, 4, 5. So it has 5 and it's missing 3. There are 3 little holes there, okay? I'll go ahead and draw those little holes in a different color. There we go. There's the hole that is the one that's missing. Carbon is missing 4 of them, and nitrogen is missing 3 of them. So which element's missing the most? Carbon. Now, carbon is oftentimes the center atom, okay? You know who's never in the middle? Hydrogen. Never in the middle. Because it only has 1 missing electron, so that it can't bond a lot of different things. Okay, now that we know that, let's go through our A. How many electrons are available? Well, we have to count all the valence electrons. We had 1 for hydrogen, 4 for carbon, and 5 for nitrogen, so that's 10. We have 10 available electrons. How many do we need? Well, hydrogen wants 2, so that's how many we need here. 2. Carbon wants 8, so that's 2, 4, 6, 8. That's 10. And then nitrogen wants 2, 4, 6, 8. That's 18. So we need 18. Let's double check and make sure I did that math right. We need 2 here. We need 8 here and 8 here. So 8 plus 8 is 16, 17, 18 are needed. How many are we going to share? When we share, it's needed minus available. So 18 minus 10 is 8. We are going to share 8 electrons. How many are going to be unshared? Well, unshared would be available minus shared. So that's 10 minus 8, which is 2. 2 electrons are unshared. So that's not a whole lot. All right, now let's see if we can write this atom. I'm going to pause it and I'm going to write it real quick. Okay, I wrote most of it down. Notice I put carbon in the middle because carbon is missing the most. And that's how the one missing the most electrons. Okay, carbon is missing the most, so it went in the middle. And then I put hydrogen and nitrogen on either side to spread them out. Now, this says we're going to share 8 electrons. Well, I can only put 2 of them between hydrogen and carbon because hydrogen can only handle 2. So there, hydrogen's happy. And I have 6 more, so I put those 3, 2, 4, 6 between carbon and nitrogen. Okay? Because they need to, that's the only place it can be. It's only between, there's only 2 options. Between carbon and hydrogen and between carbon and nitrogen. And now I have 2 unpaired electrons. So where do I put those? Well, let's think about it. If I put them right here, how many electrons would carbon have? 2, 4, 6, 8, 10. That's too many. So that's not where they go. So I'm going to erase that. Carbon, remember we're looking for an octet. We're trying to make the octet so the atom's happy. So I'm going to put the other 2 electrons way over here. Now, the reason I did that is, remember, electrons are all negative, and likes repel. So I put it as far away as I can. If I put them down here, it would be closer to these. So I put it on the opposite side, 180 degrees away, to get them as far away because they repel each other. They don't want to be close. All right, now, how does this work? Let's circle the octets. There's hydrogen's octet. What about carbon? Carbon gets to have all of these. And that's 2, 4, 6, 8. And what about nitrogen? Well, nitrogen gets to have the ones in the middle between it and carbon plus those blue on the outside. 2, 4, 6, 8. So everybody has what they want. Carbon has the octet, nitrogen has the octet, hydrogen has 2. And for every 2 electrons, we put a single bond. So carbon, there's 3 sets of 2, so 3 lines. Every 2 electrons is a bond. So, but normally we write them horizontally like this. So that's 2, every line represents 2 electrons, okay? 1 line equals 2 electrons. So 2, 4, 6, and then nitrogen with its unbonded pairs sitting off there. This is the Lewis dot structure for hydrogen cyanide. Okay, I think I'm going to do one more, and then hopefully that'll be enough to help you. Okay, I raised someone, we're going to do this one, and this one looks a little more complicated. It has 2 carbons, 5 hydrogens, and chlorine, 1 chlorine. So how do we figure out what's in the middle? Well, first of all, let's write how many valence electrons they all have. Carbon has 4. Okay, how many is it missing? It's missing 4. And you don't really need to write that down each time, but I'm doing it right now just to help us. Hydrogen has 1, and it's only missing 1. And chlorine has 7. 1, 2, 3, 4, 5, 6, 7, because it's in column 17, so it's missing 1. All right, which element's missing the most? Carbon. Now, you will find that carbon's in the middle a lot, okay? So, but I have 2 carbon atoms here. So what you do is you put both of them side by side, okay? Both of them side by side, and then you surround them north, south, east, and west with atoms. So this one could be written many different ways, and it's not really going to matter too much. So there's 3. Now there's the 4th one. The north, south, east is carbon, west is the hydrogen. So that's 3 of the hydrogens. North, south, west has a carbon, and then chlorine over here on the east. I really could have put the chlorine any place where any of those hydrogens are, and it would have been fine. And you don't need to understand fully why. We'll go over it a little bit in chapter 7, but I'm not going to worry about it right now. So this is the basic skeleton, I guess, of what this molecule would be. Now, let's count. How many electrons are available? Okay, there are 2 carbons. It has 4 valence electrons, so 4 times 2, 8 valence electrons from the carbon. Hydrogen has 1 valence electron, so 1 times 5 is 5 valence electrons from the hydrogen. And chlorine has 7 valence electrons, so 7 total. So add that all up together. 8 and 7 is 15 plus 5. We have 20 valence electrons available to use. How many are needed? Okay, well, let's think about it. We have 4 that are needed for this carbon, and there are 2 carbons. So that's going to be 4 times 2. We need 8 electrons here. 8, and then really, sorry, that's not what we do. We say every carbon needs 8, and there are 2 carbons. So carbon needs 8, and times 2, that's 16 that the carbons need, right? And then hydrogen, every hydrogen needs 2 electrons, and we have 5 hydrogens, so that's 10 electrons. And every chlorine needs 8. So how many is that? Well, that's going to be 16 plus 10 is 26. 26 plus 8 is 34. Is that correct? We need 34 total electrons in order to make all this work. Now, this is just one different way. I will go through another way with you in class as well. So, but let's just kind of go through that one more time because that was a little bit confusing. There are 2 carbon atoms. Every carbon atom needs 8, and there are 2 atoms. 8 times 2 is 16. Every hydrogen atom needs 2 electrons because it only has 1 energy level. So, and there are 5 hydrogen atoms in this molecule, just like there were 2 in the carbon. So 2 times 5 is 10. Every chlorine atom needs 8, and there's only 1. That's why there's an 8 there. So add that together, we get 34 electrons. All right, how many of these electrons are going to be shared? All right, shared is needed, which is 34 minus available. So we're going to share, it looks like we're going to share 14 electrons. And how many are going to be unshared or lone pairs? Well, that's going to be available minus shared, so that's 20 minus 14. So we're going to have 6 electrons that are unshared. So now we start off by putting the electrons in that are going to be shared. Right here, 14. Okay, hydrogen has to share with carbon and can only put 2. So that's 2, 4, 6, and that makes all those hydrogens happy. 8, 10, all right, that's sharing. 12, and 14. So now let's look and see who's happy now? Who has their octet already before we put in the unshared? Or their 2. Hydrogen has its 2. That's happy. Hydrogen has 2. Happy again. Hydrogen has 2. Happy. So circle all the hydrogens. They have the maximum amount already. So all the hydrogens are good. They only have 1 energy level. They can only hold 2. What about carbon? Well, this carbon has 8. Because the ones in the middle, they both get to share. 2, 4, 6, 8. And this carbon has, whoops, I wrote over it, but 8. Let me put that red one back so you can see it. So the carbons have their octets already. But what about chlorine? Chlorine only has 2 electrons right now. So we're going to use, how many are unshared in this? 6. Well, put them around chlorine then. 2, 4, 6. Now, chlorine has its octet. Using all kinds of pretty colors. And now, we had 20 electrons available. Did we use all 20? We can count 2, that's a single bond. 4, that's a single bond. 6, 8, 10, 12, 14, 16, 18, 20. Now those yellows are hard to see, but now we can draw this with lines. Carbon singly bonded to hydrogens. That's 2, 4, 6. Single bonded to carbon. That's 8. Singly bonded to 2 more hydrogens. Singly bonded to chlorine, and then a bunch of lone pairs. I'm double checking one more time for, do I have 20 electrons? Every line is 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. That's it. That is the Lewis dot structure for this particular molecule. Okay, I did lie. I am going to do one more because I want to do a polyatomic ion. Okay, I wrote down 2. Now these are ions because they have charges. This is NO2 with a -1 charge. So first we figure out we have nitrogen, and nitrogen has 5 valence electrons, I believe. Let's see. There it is. Nitrogen, 5. Yes, 5 valence electrons. So 1, 2, 3, 4, 5. It's missing 3. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. It's missing 2. Okay? So which one's missing the most? Well, nitrogen. Nitrogen's missing the most. So it goes in the middle. So, and also you can tell because it's alone and we want it to look the same. So we put the 2 oxygens on either side. Okay? And that way it's symmetrical. You're looking at symmetry. So how many electrons are available? All right, nitrogen has 5. Oxygen has 6, but there are 2 of them. So that's 12. We have 12 plus 5. We have 17 available electrons. How many are needed? Well, nitrogen needs 8. So there's 1 electron times 8. It needs 8. Oxygen needs 8. So there's 2 oxygen atoms times 8, so 16. Okay, remember that. It's the number of atoms times how many they need. And nitrogen wants an octet, oxygen wants an octet, but I have 2 oxygen atoms, so I have to multiply the octet times 2. I only have 1 nitrogen, so I multiply it times 1. So now let's add these together. Oh, I didn't mean to write it right over there. Sorry. Let me fix this. Okay, I moved it down here. We're calculating the total number needed, but this is how I calculate it. The 1 nitrogen times 8 is 8. The 2 oxygens times 8 is 16. And then 8 plus 16 is 24 electrons. 24 are needed. Okay? All right, now how many are shared? That's going to be the needed minus the available. So 24 minus 17. And okay, that was 7. And then how many are unshared? And unshared is available minus shared. So available minus shared, 17 minus 7, that's 10. 10 are unshared. Okay? Available is 17 minus shared is 7. Okay, now let's try to write. We have 7 shared electrons. All right, we can only put those in the middle. 1, 2, 3, 4, 5, 6, 7. And then we have 10 unshared electrons, and that would be around the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, now let's see where we have octets. All right, oxygen 2, 4, 6, 8. Nitrogen 2, 4, 6, 7. Well, that's not quite enough for nitrogen. So notice this has a -1 charge. Well, that's because really, this is adding in one more electron. So we don't really have 17. We have 18 available. So I just wanted to show you there was a problem there. So we really have 18 available. This means we added one of the negatives, one more electron in. So now we got to go back over here. We have 24 minus 18. We're actually going to share only 6 electrons. Okay, so 2, 4, 6. And we're going to, since we're sharing 6, we're going to have 11 unshared electrons. That doesn't make sense. So I must have, oh, that's right. It's 18. 18 minus 6. Okay, that makes much more sense. So that's 12 unshared electrons. Okay, so remember that. This really was 18 electrons because of this -1 charge. So that's going to change things. So we're going to erase. We're only sharing 6. So get rid of this one. I should, and this one right here. I'll go back and, whoops, sorry about that. Go away. There. Fix my oxygen. Okay, we're sharing only 6 electrons. 2, 4, 6. Okay, got it. Unshared electrons, 12. Okay, this oxygen still has the octet, 2, 4, 6, 8. We have the 6 shared electrons. The unshared electrons, though, should be 12 now. We have 2, 4, 6, 8, 10. We need one more pair of unshared electrons. Well, you should notice from this that oxygen already has its octet now. But nitrogen only has 2, 4, 6. So nitrogen is the one that gets the extra unshared. Excuse me. So now, nitrogen has an octet. 2, 4, 6, 8. The 2 pairs of electrons they share form bonds. And so those 2 form a bond. And so now we rewrite this as nitrogen with one unshared pair, a single bond to oxygen, which has these 6 unshared pair, a double bond to oxygen, which has these 4 unshared pair. Now, we added in this extra electron, so really you have to put brackets around this and a -1. Now we are going to practice this a ton, so don't worry about it if you don't have this perfect. Now we're going to do ammonium the same kind of way. There are 4 hydrogens and 1 nitrogen. That means nitrogen's going to be in the middle and hydrogen's going to be all around it. North, south, east, and west. Remember, hydrogen is never, ever in the middle. How many available electrons for this? Well, nitrogen has 5, and each hydrogen has 1, and 1 times 4 is 4. So available normally would be 5 plus 4. 5 plus those 4 would be 9. But this has, I'm going to tell you about this now instead of going through it, it has a +1 charge. And that means that we subtracted 1 negative electron. Because remember, electron is a -1 charge. So we subtracted a negative to get a +1. So we don't really have 9 electrons available. We have 8. Take 1 away. So how many are needed? Well, hydrogen needs 2, and there are 4 of them. See, hydrogen needs 2, and there are 4 of them, so that's 8. And nitrogen, there's 1, and it needs 8, so that's 8. So we need 16. 16. And erase that line. So how many are shared? Shared is needed minus available, so 16 minus 8, they're going to share 8. And how many are unshared? And unshared is available minus the shared. So that is 8 minus 8, which is 0. None of them are going to be unshared. So we're sharing all 8 available electrons. So put those in. 2, 4, 6, 8. Hydrogen and nitrogen have single bonds all the way around. Because it's a positive charge, you got to put brackets around it and a +1 sign on the outside. That's for a polyatomic ion. And each pair of electrons is a single bond. So if I wrote this completely correct, it would have these lines to represent the single bonds that represent plus all the all the pairs of electrons, and then a +1 charge. Okay, that's enough practice for now. We'll practice more together in class. I hope that helps.